Hi, I'm Simon. I'm the creator of Spacewalk, a real-time telemetry and analysis platform for games. In this video, I will show you pretty much everything you need to get started using Spacewalk. On the website, you can find a lot more information about Spacewalk in general, about its applications, plugins, the protocol that is used, tools you might want to use, and of course, most importantly, the Spacewalk application itself. So let's get started by just opening up the application. And when you first start the application, you pretty much start with a blank screen. On the top left, you have the menu button, and on the top right, you have a connection indicator, receive and transmit lights, as well as a pause button. So, Spacewalk is based on plugins. So pretty much everything you want to use in Spacewalk is its own plugin, and you can freely modify plugins, develop your own plugins, and so on. So you can easily extend the application of Spacewalk by creating your own plugins. To load a plugin, you just simply go to the menu, go to the Add Recommended Plugins list, where you can choose from recommended plugins, or you can also just load a plugin from any website, pretty much. A plugin is just a website that's then loaded into an iframe, which makes it fairly easy to deploy your own plugins to the web. But right now, we're just gonna use a recommended plugin, and the most simple plugin is the Direct Controller Visualization plugin. You simply click it, and it is already loaded in the background of the menu. So let's do away with the menu, and this is what we have right now. But if I start moving the controller, just grab the controller, you see nothing happens. Because we have to somehow get the controller data into Spacewalk. Spacewalk uses WebSockets, which is a network protocol. So everything Spacewalk goes over the network. The benefit of that is that you can have the game running on different machines, have it running on a console, on whatever device you want, and then also have Spacewalk application running on pretty much any device you want. As long as they're in the same network and are somehow able to speak to each other, then you're fine. Okay, since we're on the same machine here, I created a small tool called the Input Logger, which pretty much only reads whatever input you get from the gamepad and then sends it over the network to the Spacewalk application. Let's just start it up here. And we see the application loaded, and we also have the first controller detected. So that's good to go. But still, we don't have any inputs in Spacewalk. The reason here is that the input logger uses sockets, which is kind of an older standard, and Spacewalk uses WebSockets, which is a fairly new addition, especially for browsers. So we have to have a bridge between those two protocols. For that purpose, I also created the appropriately called bridge, which pretty much does just that. It takes whatever messages it gets from the socket connection and hands it over to WebSockets connection, and vice versa. So if you start the bridge, you see it's connected. It connected to the socket, it connected to the WebSocket, and we are good to go. I can now see movements on the controller. I can press buttons and do stuff and so on. With different operating systems, and different controllers, you usually get different button configurations. So there's already a few here. In some cases, you might want to extend that, but for most standard controllers, it might be good enough. And you can also find these settings in a few other plugins, maybe. Okay, so that's the simple plugin. Now let's do something a bit more interesting. To remove a plugin, you can load as many plugins as you want, but you probably want to remove them at some point. You just click the remove link here, and the plugin is gone. So the next plugin I want to take a look at is the Information Flow Analysis plugin. This is currently the most advanced plugin available, and the one that probably has the most use for playtesting. In the top left, you have the controller mapping as before. So we currently have an Xbox 360 controller on a Mac, but there's a few other mappings. You can also use a custom mapping that you can load and store as a file. Controller select gives us the number of controllers currently attached. So if you have more than one controller attached, you can actually select the controller that you want to use in the plugin. Then there's model data, load and store, if you actually want to export the data you created, and you can also reset it in case you don't need it anymore. Here then comes the section with the Markov chains. As mentioned in the previous video, we use Markov chains of a certain length, which means that the Markov chain is only trained by, for instance, in this case, the data that received in the last 15 seconds. So it only represents this kind of data. The higher you go with the data, the more stable the model becomes, because we have more samples available, but also the more kind of averaged your results might be. And it might not react this quickly to changing gameplay mechanics or changing parts in the game. If you select two different model lengths, then you can also see differences in the two levels in here. This graph here is probably the most important part of the information flow plugin. It gives you the information content of the analog sticks as well as digital input, which is buttons, and it combines it into one view. So this is kind of the grand total of the information content that is currently flowing through the controller. Down here, we then have a bit of model exploration. You can see here a visualization of the model. Let me just set it to 15 seconds so that I can see the effects a bit quicker. There we go. These two plots, one for the left analog stick and one for the right analog sticks, give us the probability of being in a certain position. The more red and the more bright the color is, the higher the probability is that the stick is actually in that position. So currently I'm just circling the stick around. And if I let go of the stick and we're coming back to the center, you see that the probability is increasing where the stick is right now, because the model only covers 15 seconds right now. You have the same for the right stick. If I move it around, you can see it changing here. Just turn that off. And on this side, we have a so-called quiver plot or vector field or flow visualization. It shows you where the controller went next once it's been to a certain position. So these arrows here, switch the arrows, means that the average from here, the average next location was here. So that gives you the kind of the where did it move next. This is where has it been, and this is where did it move next. And you can select between just this standard arrow plot where you have one arrow for each cell, or you can also use a quiver plot, which is more like a flow visualization. You can also compare model A and model B to each other. You can just overlay the quivers, or you can also just overlay the arrows. And additionally, we can also show the error, which means the mismatch between the two models, which might be very interesting in some cases. A bit further down here, we see a matrix plot of the probability, which kind of is similar to, the flow visualization. In here, we see for each field what is the kind of the next field we're going to. So let's say we are. Let's go in circles a bit to see some data. All right, it should be enough. Okay, for example, let's say we are in this position. So what are the probabilities of going to other fields afterwards? And it turns out that the highest probability is going to one of those three fields. And you can take a look at that for each of those cells. And at the bottom, you pretty much have a similar thing as with the analog sticks, but it's just for the triggers, and hence it's just 1D. And having a flow visualization didn't make that much sense in here, so that's why we left it out. Okay, coming back to the actual data. Now, since we're training these these models on the fly. What you see here is the information content of the user input, which means how surprising in some sense was that user input currently. How good or bad could we actually describe the user input with the stochastic model that we already have from the user input. The idea is that the more bandwidth, the more information, the more interaction is needed from the user, the higher the information content would be. So games that require very little interaction would have very little information content or information flow in this plot. And games that are very taxing for the player, require a lot of skill maybe to some extent, or racing games where the player constantly has to move, they have usually a quite higher information bandwidth requirement than other games. So this can be one aspect to analyze how much interaction is actually between the player and the game. What you can also see here are these dark gray bars. Since we're only sampling a model, or the model is based on sampled data, we might not always have enough data to really compute the information values. In this case, we just get invalid data, and which is identified as these bars. But you can also see the longer the model is we use, the better the model becomes and less invalid data we get usually. So there's a bit of a trade-off between being a bit more agile or having a bit more robust, a robust model. Another thing that you can see here is we have model A on top and model B on bottom. And you see they are fairly equal, but they might as well also be quite different at some times. And the difference is indicated by these brighter gray parts. So having these parts here means that the bar on either side is shorter or longer by that amount. This should give you kind of a visual guide or visual aid to quickly compare those two models. Difference in the model outcome can, for instance, occur when something changes in a game. Play interaction changes, maybe the game changes or the player changes because they learned something new, they are trying out something new, they're starting to button mash because they have no idea where to go next. And these are things that you can see in differences in the two models if you're using differently sized or models of different length.